GMGM, welcome to another Touchgrass podcast episode. We've been seeing IBRL all across the timeline. Austin's been on panels on the timeline. Everyone in Solana is talking about Double Zero. We did our podcast with the Shelby team, and they also mentioned Double Zero. I think a lot of our audience has been really curious about what Double Zero is and understanding sort of the nitty gritty of it. So we obviously had to invite Austin on the show. Austin, thank you so much for the time.
Hey, thanks for having me.
Awesome. Obviously, people who've been in the industry know you, since the Solana days and even before then. Do you want to give it like a quick background about yourself, and then we can sort of get into like what IBRL is, what Double Zero is, and talk more on there.
Yeah, certainly. So I got into crypto in maybe 2016, 2017, kind of accidentally. I was working for a fintech company that was in the process of failing, and they were trying to build a borrow lend token on Ethereum to save themselves. It didn't work, but I got hooked on the bug there. Went to work for Republic, launched Republic Crypto with them, and then went on to work for Bison Trails, and that basically, which is like a blockchain infrastructure company, did a lot of really cool stuff in the early days of Ethereum's proof of stake transition. They got acquired by Coinbase. Coinbase is a great company. I thought it wasn't necessarily the place I wanted to go, and joined Solana right at the end of 2020. And so spent the last about 4.5 years there doing a bunch of things, from running product to marketing to communications to ending up running strategy for the last about 2 years there, and then left to co-found DoubleZero with two other incredible co-founders.
Awesome. Can you talk to us about the Double Zero thesis? Like maybe take us back to when you first heard about it. How did this idea come about? And who came up with like IBRL as like
Yeah.
the acronym for this?
So one of the crazy things about the DoubleZero founding story is it was kind of founded 2 or 3 times, depending on how you count. And so Matteo, one of my co-founders, actually had the idea to build DoubleZero back in like 2017. He was sort of working with a bunch of high frequency trading firms, and his career and background is basically building and managing infrastructure for high frequency trading firms and other latency sensitive applications. And so, he started off in fiber back in the late 90s, moved into the microwave tower work that was going on, and eventually even shortwave radio, which is what like the state of the art is for HFTs today. At least the state of the art they tell us about. Who knows what they're actually doing behind the scenes. But he sort of had this idea back around then that says, look, if crypto is really going to be the next epicenter of trading, like it can't be running on the public internet. This is crazy. Now, back then, blockchains were just too slow for something like DoubleZero to make sense. The fastest stuff out there was Ethereum with 12.5-second block times. And, there was no real speed advantage at that point. But you fast forward a few years, and I was talking with a bunch of the folks who worked on the FireDancer project, which was this initiative in Solana to develop a new validator client from the ground up, to build it from first principles for speed and performance. Many of those learnings have now come into the Agave client, which Anza builds as well. So there's two super high performant clients for Solana. But one of the things we kept running into was like we built this incredibly powerful validator client, but it couldn't reach its potential on the public internet. And this was something we sort of knew from the beginning was going to be some sort of a problem. But the question with these things is always like, well, when are you really going to run into it? And so back in 2022, like Toli and I were talking about like, oh, what if Solana Foundation built this high performance fiber network? Would anyone trust it? Would that be too centralizing? Could we just buy every validator a 10 gig internet connection? It's like, well, there's a whole other sort of problems with the public internet. But this was really for me the eye-opening moment of saying, like, if we don't address the core problems of blockchain, which is that at the end of the day, we're running over the public internet for everything, we're never going to really be able to compete with TradFi. Now, the public internet's great if you're trying to, send Bitcoin transactions or you're trying to propagate block data in 12.5 seconds, but it's not really competitive with anything in traditional finance, which is what we talk about as crypto wanting to actually compete with. And so that was sort of the initial idea of DoubleZero is could we build this high performance distributed fiber network around the world that was run by multiple independent contributors and had more transparency than the public internet, more verifiability than the public internet, and wasn't run by one central company. And that's what we have today now with DoubleZero.
Awesome. For our audience who usually looks at infra in blockchain infrastructure in these stack layers where different middleware, the L1 and on top of it. And we recently had the multi-coin partners on, and they have mentioned that the L1 trade might be done, but there are so many layers of the stack that are yet to be built. So could you kind of explain where double zero kind of fits into that stack for someone who might not be aware of what fiber optics are?
Yeah, it's really funny because in blockchain, we always talk about like a layer one or a layer two protocol. And, layer one and layer two comes from the OSI view of the world that most of us learned in ComSci 101 is that there's these 7 layers of the networking stack. And, you can go through that process and see what they look like. But everything in blockchain is not a layer one or layer two protocol. They're a layer 5, layer 6, layer 7 protocol in the OSI view of the world. And so when crypto people talk about a layer one network, what they're really talking about is not necessarily like a layer one blockchain in the traditional sense of a computer science perspective. So what we basically said is let's throw this all away. Let's go back to first principles. The physical connections are the most important component in a system's performance. Like literally, if you are trying to minimize the amount of time it takes to go around the world, you got to go in the straightest line possible and the most direct line possible. And so the internet is not good at that. The internet is incredible at low cost data transmission and reach. You can reach any server anywhere in the world for about $40 a month. That is an incredible achievement of capitalism and human ingenuity, but it's not built for high performance. And so we sort of started from first principles and we said, okay, if we are going to focus on building a system that is high performance, we have to start with the physical infrastructure first. And so when we talk about DoubleZero running on physical fiber cables, like we really mean like this is a deeply physical network. And so if you go to doublezero.xyz/dashboard, you can see in real time like what these fiber lines are, where they run, what entity is contributing them to the DoubleZero network, and how they work and how the whole thing runs. And so when we're thinking about like a layer one protocol as DoubleZero, we mean OSI layer 1, 2, and 3. And so we sit far below the infrastructure layer that most people think of when they think of blockchain. So, you can't take a user deployable smart contract and deploy it on DoubleZero. It's really meant for other layer ones and layer twos and RPCs and trade servers and all sorts of things to operate on this network. The same way that if you spin up a server in a data center, there's a Ethernet cable plugged into the back and that goes to the public internet. Well, the whole thing with DoubleZero is you add a second Ethernet port and that goes to the DoubleZero network. And that's the same type of private high performance network that you see, Google and OpenAI and Microsoft and Amazon and Jane Street and Citadel and all of these companies running, except they've always had them as just private for them. This is really a shared infrastructure model to give blockchain a new underpinning to allow it to go faster than the public internet limits it to now, and also compete more directly with traditional finance.
Awesome. So would you say that this is more like a hardware problem that you're solving that others are not?
Yeah, it's a good question. So I would say there's a massive hardware component to the DoubleZero network, but at its core, what we build at the DoubleZero Foundation, what the folks at Malbec Labs build, and the other core contributors, is the same as any other blockchain system. It is a software package that allows something to happen. Now, most of the time, what you're coordinating is decentralized compute. We don't really think of like Solana as a compute network, but it is at the end of the day. It's a storage and compute network. It's a giant virtual machine spread across multiple different servers all around the world, about 1,000 for Solana, and all of those run sort of this distributed computer. What we work on at the DoubleZero network and foundation is this software that allows multiple independent contributors to take their different pieces of fiber lines they have around the world and have it appear as one homogeneous global network, even though under the hood it's run by all these different contributors. The same way that like the Ethereum blockchain or the Solana blockchain appears as one homogeneous system, even though it's run by hundreds of different entities under the hood.
And I think that makes a lot of sense. And Austin, like we've talked a lot about, the way that DoubleZero impacts Solana. Last I checked the adoption stats, like I think 44% of all validators are using DoubleZero right now.
Yep.
Can you talk to me a little bit about, what does that mean when we say 44% adoption? Like when these validators sort of connect into the DoubleZero network, what does that enable for them? And how do these conversations typically go? Is it more of a BD conversation? Is there inbound? What's sort of the landscape there look like right
Sure.
now?
So one of the cool things about DoubleZero is it's the first permissionless high performance network that's ever been built. So let alone the first one run by multiple independent parties. But if you are a Solana validator, you can just download the DoubleZero software and connect your validator to the nearest DoubleZero device to you permissionlessly. There's no approvals involved. We're not running anything on our end that allows that to happen. What happens is the DoubleZero ledger, which does run some form of a blockchain under the hood, is basically looking at the Solana leader schedule and saying, hey, is your validator staked? Is it, building blocks? Great, perfect. You're able to connect in. And so from that perspective, this is a really sort of turnkey automatic system. It takes less than 5 minutes to set up for a validator, and they're able to access a faster fiber network than they would be able to otherwise. Now, the trade-off with the DoubleZero network is we are not everywhere, right? You can DPIN is probably not exactly the right way to think of the DoubleZero network, but most DPIN networks are high reach, low quality. And that's the trade-off you get, right? A Helium hotspot is less performant than a Verizon cell tower, but you can put it up yourself anywhere you need it. And that's the huge advantage that they're getting. DoubleZero is the opposite. It does not reach as many places as the public internet. I can't get a DoubleZero connection in my house in New York, but it's much more performant than the public internet. And so that's kind of the way that this works. Is our contributor network expands this network globally. We're in a ton of different regions all around the world at the moment, but we're not truly everywhere. And so, sometimes a validator might say, oh, like if you're running in, we have no connectivity, for example, down to South Africa where there's a number of validators running. We'd love to have a contributor come in and contribute that line. But where the DoubleZero network is available, it's significantly more performant than the public internet. And that's kind of the whole purpose behind the network.
So it's like the process of expanding, is it more gradual, or is there like an internal efforts of expanding it with more and more partners, or are you expecting it to grow more like a blockchain network where more and more people will join? How does that like expansion look like? Is it going to be more linear, or how does it look like?
Yeah, so it's entirely, like all things in blockchain, capitalist driven. So if there's an economic incentive to provide connectivity somewhere, it will happen, right? That's just capitalism 101. Markets are efficient at serving needs. And so what we basically see is there's a bunch of areas where, like South America is a great example of this, right? It's quite hard to run a Solana validator in South America without sort of a performance hit on it. We had a bunch of folks band together, and there's 24 validators operating in Sao Paulo in Brazil that basically all banded together and said, like, hey, we're willing to contribute a bit to making this fiber connection down there possible. And a network contributor came in and said, great, we'll provide connectivity down here. And so demand is basically the biggest driver of additional connectivity and expansion. So I know you guys have talked to Shelby previously. They have new locations in the world that they need connectivity that, the DoubleZero network covers the majority of it, but there's a few of their upcoming applications that are going to be deploying on Shelby that need fast connectivity into a new market. And the cool thing is there's basically two ways this can work. The Shelby team can say, well, we're just going to deploy it ourselves. And, that's the beautiful thing about this network is you can bring it to everywhere you need to, just like a DPIN network, but they can also go out and say, hey, here's what the utilization is going to be. There's probably a economic opportunity for a network contributor to run connectivity to this city that we need it in and earn rewards based on that. And so the beauty of this system is the most profitable cities to provide connectivity to are the ones that have the most competition. And this is a really key point about how the reward system works in DoubleZero. It's not stake weighted. It's like Bitcoin, right? Bitcoin rewards hash power. It doesn't reward how many Bitcoins you have. And so, if I have 10% of the hash power of Bitcoin, I'm going to get 10% of the rewards. Doesn't matter if I'm Michael Saylor or if I just bought my first Bitcoin yesterday. And so the DoubleZero network works in the same way. And this is really about making sure that over the long term, there's competition to make sure that incumbents are always challenged to provide the highest performing infrastructure, and someone else can always have the opportunity to compete with them and bring in faster connectivity.
Yeah, I think you mentioned incumbents. That was going to be my next question, because I think I read it like a couple of years back, and I don't know, I think it was Gurley who talked about it in kind of a panel about how telecommunication used to be this big industry, and after 20 years, it was just two people owning the entire market share.
Yeah.
Because these are such massive companies, and you are, as you said, competition is fierce, and you are providing better performance. How do you kind of work with them, or because they have, as they've been here for a long time and you're coming new, how do you kind of uh, get into their share? You're not trying to, even though you're providing a better service, it can still be very hard. Is that like
Yeah.
working with them, or how does it work? Because they still control the entire market and they're all over the world.
Yeah, it's kind of interesting. So the reason we work on this network contributor model as opposed to building out the fiber network ourselves is because different companies have different types of exposure to these various types of networks. So some of the network contributors to DoubleZero, they own fiber. Other ones are leasing fiber. Some of them, it's that they took a long-term lease on a piece of fiber, but now maybe they don't need it because they've gotten something else faster, and they're contributing that sort of unused capacity to the DoubleZero network. There are actually some proper carriers we're in touch with. You can think of sort of like the AT&Ts and the NTTs or the SK Telecoms of the world that are interested in contributing fiber directly to the DoubleZero network that they own. Now, there's all sorts of other issues with that because a large enterprise is usually not set up to accept tokens. But one of the cool things about the DoubleZero network is we received a no action letter from the Securities and Exchange Commission basically detailing that the payments of the token to contributors are not securities transactions. And so this major hurdle for most companies where, oh, we can't touch crypto because what if it happens to be a security? There's not that concern with the DoubleZero network. So we're making progress, but as you might imagine, big companies move slowly when it comes to these types of things.
And then Austin, I want to ask you, you said that the cities where competition is heavy, like the networks is incentivized for competition to get even more cutthroat in those cities. Is that sort of how, like, what are some of the top cities right now? I'm just curious.
Yeah, so it basically mirrors where the concentrations of stake are in Solana at the moment, which is largely in Central Europe.
Okay.
And so there's a lot of competition for Central Europe, but the beauty of the network is it rewards performance over the public internet. And so when you're dealing with like continental Europe, especially like within Germany, internet's pretty good, right? And so those folks, while they may have the most validators connected and the most traffic flowing over it, their advantage over the public internet is lessened compared to, say, a super fast route that runs from Frankfurt to Tokyo, or someone providing connectivity through Singapore up into Asia, or a long haul route across the Pacific. And so, as we basically see geographic expansion of the Solana network continue, and we see larger performance advantages of the DoubleZero network relative to the public internet, it changes the dynamics of what's the most profitable links on the network. And that's kind of the beauty of it, is it's not just rewarding connectivity or rewarding use. It has to be faster than the public internet alternative. Otherwise, people should just use the public internet.
That makes sense. And I remember listening to your talk at Solana Breakpoint in December. You showed this beautiful map, and like there was just this one big red blob in Europe. Let's talk a little bit about that. I think, and that extremely well segues into the delegation program that you guys are running as well. Do you have any thoughts on why the Solana stake map is so heavily centered towards Europe? Like, is
Yeah.
this is where the early contributors Solana were? Is this more like the internet is fast there, that's why is there, like, why is that, and why is there a concrete effort to decentralize that away from Europe? I think those are the two things that we want to understand, and then we'll talk about how the delegation program helps that.
Yeah, I think there's kind of a few things to think about here. One is sort of the historic nature of Solana, which is that this was a protocol that was founded and then launched in the depths of first the 2017 bear market or 2018 bear market, and then the COVID bear market. And so what you basically saw were an aggressive focus on practicality. And Europe at the time had the cheapest and the most abundant bare metal hosting providers. Now, bare metal is like a fairly old thing in Solana. It's pretty new for the rest of crypto. The majority of nodes are run in the cloud in the majority of ecosystems, except for the Cosmos ecosystem and the Solana ecosystem. And so bare metal providers historically, and sorry, just to like go back, bare metal providers are basically like, instead of renting the concept of a server, which is what you get from a cloud provider, you're literally renting a physical server. Like a guy can point to a machine in the rack and say, that's your server. Whereas on AWS, it's kind of the concept of a server, and that sometimes the underlying infrastructure gets swapped out, and this is the whole point of virtualized systems. But virtualized systems have these overheads on them that networks like Solana really struggle with because it's such a performance optimized piece of software. So bare metal providers historically were concentrated in Europe, and that was kind of where the cost to performance ratio was. And since Solana was like a pretty Solana was not like a ascendant protocol when it launched, right? Solana Labs almost went bankrupt 9 months after the network launched. Like this was very much one of these situations where it was not clear that the that the Solana network was gonna win at the beginning. And so there's a lot of historic reasons why it's centered in Europe. The problem is, once you get a concentration, it's very hard to deconcentrate a network like this. And the reason for that is there's advantages in being close to your neighbors, right? This is why Hyperliquid is all located in Tokyo, is because there's advantages of being co-located. And so what you have to do when you think about this is, what's the long-term vision of the network and how do you keep things decentralized? Not just for the moralistic crypto values reasons, because what we've seen in this industry are like, morals and values are awesome, but profits will always take priority. So you need to actually make it more profitable to support decentralization. And there's two major initiatives for that. The first is Solana's multiple concurrent leaders roadmap. And the idea for this is you'll have, 2 entities or 20 entities building blocks simultaneously in multiple parts of the world. And that's actually the huge advantage, is that when a news event or a market event happens in Tokyo or Hong Kong or Singapore or Buenos Aires or, Germany, the distance you are running to get your transaction in is small, right? If all the validators are in Germany, then, if a news event happens in New York, well, you've got to fly all the way across the Atlantic before you can land that transaction and get that news event in. And so with multiple concurrent leaders, you can have multiple block builders all around the world. This is, you can sort of joke that this is actually the true roll-up centric roadmap of Ethereum. But it's the same kind of concept under the hood, is that you should have local markets that roll up to larger markets. And the beauty of this is it creates a real advantage economically for decentralization, not just a security and values argument. Now, we're not there yet, right? Multiple concurrent leaders is not live on Solana. Alpenglow is not shipped. And so one of the things that we've been doing at DoubleZero is this new sort of phase 2 of the DoubleZero Delegation Program. And the whole concept of this is to make it more economically feasible to run validators outside of Central Europe, and to incentivize folks to move those nodes, because that actually improves the resiliency of the entire Solana network and, helps us move forward towards this multiple concurrent leaders role. And so, we have this stake pool that's contributed by, a number of investors and users. Unfortunately, it's not all of our money. I wish it was. But, the way that program now works from a delegation perspective, or will start working in the next week or two, is that it rewards folks who are moving outside of central hubs into other locations. And so we're launching with about 4 different cities that are target locations for this program. And there's basically about 600,000 SOL per city or per market that's available. And how is this calculated? Well, the same way it would be normally, is it's proportional to stake weight. So if you are the only validator connected in Hong Kong, you will get 600,000 SOL staked to you. Now, that won't last very long, because this is the beauty of capitalism, is people move to markets where there's opportunity. And so over time, this will all balance out. But that's really the goal, is to incentivize people to move away from where the stake core is now, but to also move to areas where there is fast DoubleZero fiber and connectivity, so that over time, there's no penalty for geographic decentralization. And in the short run, the additional stake from the program makes up, or more than makes up, for any hit someone might take. But we've seen people move servers for 10 bips of more MEV. There's a lot of cost optimization going on right now, especially in this like quasi bear market that we're in.
That makes sense. And just to clarify, the four cities that are optimized right now, are they optimized based on where the double zero network is the fastest or where it would help the Solana network the most? Like, how are those cities optimized and what are those four cities for
Yeah,
our listeners?
totally. So, if you're connected down in Sao Paulo, if you're in Singapore, if you're in Tokyo, Hong Kong, those are all sort of, and the U.S. to some extent too. Those are kind of the target markets at the moment. Now, Australia is not on the list, Africa is not on the list, and it's not on the list because we don't have fast fiber connectivity down into there. So, this is first and foremost a double zero stake pool program, right? This is for the betterment of Solana, but it also has to have connections to the double zero network. And so, if someone comes in and says, "Oh, we want to bring fast connectivity into, let's say, South Africa or something like that," we would certainly add that city to the list, but it is limited to locations where we have fast fiber.
That makes sense. And Austin, like talking about expanding these fiber, physical fiber contributors, when you talk to some of these people who want to join the network, is there like a list of criteria that you have for these? Like, how do you vet these contributors? What is the process of onboarding them? How does one become part of the Double Zero network?
Yeah, so on docs.malbeclabs.com, you can find all the information about becoming a contributor. It is still a process where someone has to like be involved and have a conversation. And the reason for that is simply because at some point there's a human in a data center somewhere that has to plug a cable into a cable. And so we can talk a lot about like permissionless, decentralized, no human involved systems, but that only works at the software layer. So what we say is like double zero contributors, it is a permissionless process in the sense that we are not, approving and denying based on the whims of what we feel like on a given day. But, at some point, a person has to sign a document that says, I'm allowed to plug this cable into this cable. And so what we basically use is what's called wavelength service. So there's lots of different types of service you can get in terms of private connectivity. There's IP transport service, which is sort of like, you're buying like, 100 megabytes per second from one point to another point. And that's what's called an IP transit service. And that tends to be faster than the public internet, but not that much faster because it still has to go through all the switching and management layer. And so what we use is it was called wavelength service. And that's basically, I mean, how nerdy do you guys want to get on how fiber optics work?
We can get as nerdy as you want.
Okay, so one of the cool things about fiber, which is not true of almost anything else in technology, is that old fiber installed 20 years ago, can be modernized just by upgrading effectively the lasers on either end of the fiber. And so, what modern high performance optics can do maybe 160 different wavelengths of light, different channels. And each of those channels nowadays can be upwards of 400 gigabits per second. And the top of the line new stuff that's coming out is 800. And so if you think about that, you can say, okay, there's this piece of fiber across the Atlantic, and we can do, 800 times 160 is a lot of bandwidth. And so when you're contributing a wavelength, the double zero network, what you're contributing is one of those 160 pieces of spectrum. And so what this means, though, is that there's no layer 3 switching in the mix. There's no, everything is basically just as optimized and close to the hardware layer as we can get. And that means it allows the double zero network to optimize that for as fast as possible with low latency and virtually zero jitter on the network as well. And that's kind of
Yeah.
one of the main advantages.
So one thing that I want to like for people to understand, and you're obviously making these very big improvements to the fiber optics technology. When was the last time such a drastic improvement was made? I don't think it was recent, right? So because all these same companies have been controlling the market, when was the last time like a big, exponential shift has happened where you would say that what double Brazil bringing is similar to that? How many years back should we go?
I mean, it depends what we're looking at. I would say it's sort of similar to when Bitcoin moved to mining on ASICs. Like there was this change where the price of Bitcoin got high enough where a bunch of people were like, "Oh, we can afford to build custom circuitry for Bitcoin." And that was like a huge unlock in the Bitcoin mining space. You see hash rate just go through the roof when people actually get into it and say, "Okay, we can build processors just for this." when we look at the DoubleZero network and we kind of look at this and say, how much of a performance increase is this over the public internet? Well, there's two ways to look at this, right? One is like, what is the latency improvement? Then what is the improvement in reliability and consistency? And both of those are significantly higher, but we're not talking like 1,000 times faster than the public internet. What we're talking about is, maybe 30 to 40 to 60% at the high end, more performant than the public internet. The real difference becomes there's a whole suite of technologies you can use on the DoubleZero network that you cannot use over the public internet, like multicast. And that's where we start to see these like massive step function improvement changes. I mean, Jito's shred stream, which is the system they use to distribute data all around the world, by switching that over to multicast on DoubleZero, the bandwidth savings are 99.96%. That is a massive, massive reduction in bandwidth usage, which not only reduces cost for everyone, but it increases the speed at which data propagates. And so when you take the package together, this is a pretty substantial improvement for any type of high performance system that's willing to adopt the DoubleZero technology stack. And it's a piecemeal thing, right? You don't have to say, okay, we're doing everything day one. It's like, we're just going to take our existing systems and run them on the DoubleZero network. That'll be faster. And then over time, you can start incorporating these new technologies to really get the full advantage. But stuff like multicast, multicast is this sort of hardware acceleration for packet replication. So what happens today on Solana is there's this big turbine tree. And so I build a block, I send it to a root node. That root node sends it to 200 of its friends. Those send it to 200 of their friends. It sends 200 of their friends. And eventually the data propagates all around the world, which is great, but it's quite slow. It's also not geographic aware. So you may have a validator in Frankfurt sending to a validator in New York, which then sends back to the validator in Frankfurt. So it can be very slow and cumbersome to propagate data. With multicast, the validators has to send the data twice. So primary copy, backup copy, and then the network switches propagate that all around the world. And so this is substantially faster than the public internet, but it's also substantially faster than Turbine because Turbine is not geographically aware and multicast is. And so not only are we able to speed up data propagation simply because the fiber is faster and the network's faster, but we can use technologies that are not available on the public internet to speed it up even more.
And then also, like, with all these advancements and how these fiber cables enhance Solana, are there like other use cases for DoubleZero as well, or is this like just mainly concentrated for what the Solana stack is? I want to
No,
understand
so we
broader
base
this goes. Yeah.
Yeah, exactly. So the whole purpose of this is to accelerate all types of high performance distributed systems. Now, today, the biggest and best of those are blockchains. And so, we started with Solana because Solana is the hardest. Solana is the if you kind of graph like transactions per second to validator count, no one else is where Solana is. There are networks that are as fast as Solana or even slightly faster than Solana, but they have significantly fewer nodes. And so being able to support Solana is like the gold standard of infrastructure in blockchain today. But, if you think about it, Google is a high performance distributed system. They have servers all around the world and they have, AI systems and Google Docs and just the search process and YouTube and all these things. And they have to synchronize all of that information as well. So while Google is not a decentralized globally distributed system, it is still a distributed global system. And from those sorts of applications, they all run on private high performance fiber networks as well. The difference is they run and manage their own. And we have a different approach, obviously, here at DoubleZero. But that doesn't mean that all of these customers out there that currently operate high performance distributed networks, a lot of them don't necessarily want to do this. They do it because they have no other option. And so you can sort of think about this as like before the cloud came along. If you were a startup and you needed to run a server, what'd you do? Well, you called up a data center, you send them a bunch of money, and maybe 2 or 3 weeks later, the servers would be online and ready. And the major innovation of Amazon was I can just show up with a credit card and I can pay someone, and 45 seconds later, I've got 40 servers ready to go. That does not exist today for connectivity. You'd think it would. You'd think there'd be like a website you can go to and just say, hey, I need 150 gigabits per second from this data center to this data center, and boom, we're off and running. That is not actually how it works. And so, with the way we basically build this at DoubleZero, like we think that's one of the main long-term advantages of the DoubleZero network is that it can all be highly programmable from this perspective. And we're doing basically for connectivity what the cloud did for compute, except it's all powered by blockchain under the hood.
Yeah. So looking ahead, I just want to ask, because you mentioned Google and data centers, because I see a future where everyone will be, obviously, there'll be all these frontier models, but as you said, they'll be running their own private stuff. And as users, we probably will run our own models with our own data and stuff. Do you think that will be like a big use case of decentralized training, and where connectivity plays a big role? Is that something you're thinking about? Because that's kind of the world we're headed.
It is, yeah. I would say that when people think about like decentralized training, it's not exactly what we think of when we say decentralized training. So it means like, oh, I've got a 5090 in my apartment. Let me, do some AI workload training. That was maybe what people meant 2 years ago, but now when we talk about decentralized training, what we mean is using professional industry-grade resources that are just geographically distributed and being able to dynamically shift those workloads around based on the cost of electricity and the cost of running GPUs at any given moment. So if you look at a company like News Research or something like that, they tend to be the sort of your second tier buyers of GPU space. And sometimes that's running on, sort of blockchain powered clusters, but usually that's just running on, random data centers in between jobs. They'll start doing some of the, News Research type stuff. The companies that basically can't afford to build their own data centers yet. They have a huge problem, though, of moving data and training models all around the world on the public internet. And you think about this, most of our data centers nowadays for non-AI workloads, they're located fairly close to the population centers, right? If I'm sitting here in New York, like my data centers are all in New Jersey. There's a few out on Long Island. Most are just over in New Jersey. And that's great. The problem with AI loads is they are so power intensive that they cannot be installed on the same power grids. They just, the data load is higher, but really what it is the power density is so much higher. So you need, 4 to 10 times as much power to run an AI data center as you do, any other type of compute-based data center. And so they're located further out where the power grids are possible, or you can run a bunch of gas turbines to generate electricity for them. And what that means is the data is actually, for the first time, traveling much longer. That when you're talking to Claude, it's not going 100 miles. It's going maybe 500 or 1,000 miles to actually get those answers. And so in that model, like especially as we start to see more work around like co-work and all these coding agents that are literally coding with you, it's now moving your code from your computer up to their system and going back and forth constantly. And so the volume of data movement and the distance that data has to move is only increasing. You can't cache it locally the same way you can Netflix or YouTube or something like that, because each query is a boutique custom query that needs a boutique custom answer. If I'm watching the same YouTube video as you, like there's no additional work that has to be done on the server end. You just have to send me the data, and that can all be stored very locally.
That makes sense. So what I'm hearing is we'll soon have like a Claude Max Plus powered by DoubleZero. That's like $400 just to make all the AI agents go faster. That's probably a use case. That's probably some of the stuff we were
if anyone
exploring.
from Anthropic is listening, I would love to chat.
Cool. Awesome. Austin, we are at time. This has been awesome. One of the idea, KG, between me and you, like one of the ideas that I was shooting with Austin in Hong Kong was there is a fiber optic cable in Mumbai. So when we're in Mumbai, we can do like an IRL recording of what a DoubleZero fiber optic cable actually looks like. So that's one to look out for. But Austin, this has been awesome. This has been super informational. I feel like all the panels, everything that you do is just top class, and it's just an educational masterclass for anyone listening. This has been a real treat for me and KG, and I hope our listeners as well. Thank you so much for the time.
Yeah, thank you. Appreciate it.